is equal to 6x squared plus 5 raised to the 4th power times x cubed minus 7 raised to the 3rd power. Now, this looks similar to number 1, but one big difference here is that I don't have a big bear hug around the entire function. Part of my function is raised to the 4th power, and part of it is raised to the 3rd power. Okay? So because I don't have that big enveloping outside parentheses, I don't have an outside and then an inside function, I'm not going to be using the chain rule to start. Even though, yes, I do see some chain rule type things going on in there, my big structure here is that I really have two functions that are multiplied together. And so I've got a first function and a second function, and they are multiplied together, which means I need to use the product rule. So product rule is the first thing that I want to work with on number 2. All right, so product rule says first, 6x squared plus 5 raised to the 4th times the derivative of the second, the derivative of x cubed minus 7 raised to the 3rd, plus second, x cubed minus 7 raised to the 3rd, times the derivative of the first, 6x squared plus 5 raised to the 4th power. All right, so because I didn't have one big bear hug around the entire expression, I'm thinking of this as two separate functions multiplied together. I apply the product rule. Any questions about writing this down so far? All right, so now I go ahead and I analyze this, and well, this first function is just written down, so I can literally just recopy this. 6x squared plus 5 raised to the 4th power. And here, I'm trying to find the derivative of x cubed minus 7 raised to the 3rd. So I might pull that offline over here, and I might just say, okay, y equals x cubed minus 7 raised to the 3rd. So I'm going to be using the chain rule on this thing, okay, because the x cubed minus 7 is all snuggled in and raised to the 3rd. So our derivative will look like, well, let's see, our inside is x cubed minus 7. Our outside is x cubed. Derivative of the outside, keeping the inside the same, my derivative of my outside is 3x squared, so 3x cubed minus 7 squared times the derivative of my inside, which is 3x squared. All right, so that is our derivative of x cubed minus 7 raised to the 3rd. So we've got 3 times x cubed minus 7 squared times 3x squared. So this is our first times the derivative of the second plus second x cubed minus 7 raised to the 3rd times the derivative of the first. All right, and so our first was y is equal to 6x squared plus 5 raised to the 4th. And so to take the derivative of the first, well, let's see, we have an inside and we have an outside. So we have a chain rule. So our inside function is 6x squared plus 5. Our outside function is x to the 4th. Derivative of the outside, keeping the inside the same, the derivative of the outside is 4x cubed. So we've got 4 times 6x squared plus 5 raised to the 3rd times the derivative of the inside, which is 12x. All right, so we've got first times derivative of the second plus second times derivative of the first. Our derivative of the first is 4 times, uh-oh, I'm going to have to erase this other derivative here. Sorry, Scratchwork, it's on my way. 4 times 6x squared plus 5 raised to the third times 12x. And this is our derivative of the first. This is our h prime of x. Whew. All right, so let's think about the strategies here. On this example, there was chain rule floating in here because I saw functions nested inside of other functions. But the bigger picture up here was that I had two really separate functions that were multiplied together. So the first thing that I looked at was, I want to apply the product rule. On the other example, which I don't have written up there, everything was surrounded by a set of parentheses and everything was raised to the fourth power. In that case, the first thing we did is use the chain rule. All right, any questions about either number 1 or number 2?